Hey guys, this is Carrie, and this is the answer key to homework number 6. So if f of x is this function, 2x minus 4 divided by 5, then for what value of a does f of a equal 2? So really important with these problems is a is the input, 2 is the output. So when we input a into our function, it becomes 2a minus 4 over 5 equals our output, 2. Alright, so now all we have to do is solve for a. So we multiply by 5 on both sides. We get 2a minus 4 equals 10. We add 4 on both sides. We get 2a equals 14. We divide by 2 on both sides. We get a equals 7. For problem b, it looks very similar. For what value of b does f of 2 equal b? This time, because 2 is in the parentheses, 2 is the input, and b is the output. So we'll input 2 into our function. That becomes 2 times 2 minus 4 over 5 gives us an output of b. And this is a strange looking problem because b has already been isolated. So the only thing we have to do is simplify the left-hand side. That gives us 4 minus 4 over 5 equals b. 0 over 5 equals b. 0 divided by 5 is 0, so b equals 0. For problem 2, determine the domain and range. So domain is all of the included x values, and range is all of the included y values. So let's start with domain. So if we look at the lowest x value that appears on our graph, that's going to be the most negative, which is this one right here. This is x equals negative 6. The highest x value that appears on our graph, so we have all of these x values in between, and then this point being the rightmost, this is the highest x value that we get. This is x equals 8. So we have negative 6 is less than all the x values on our graph, and all the x values on our graph are less than 8. Finally, because we have the solid bubble at 8, it means that x is allowed to equal 8 because it actually hits that point. So I chose to use inequality notation, but judging by the survey in class, many of you prefer interval notation. So the interval notation solution would have been negative 6, comma 8 with the square bracket. Range is the exact same thing, but in the y direction. So we want to find the lowest y value. So the lowest y value that we have is going to be right here. And that's negative 1, negative 2, negative 3, negative 4. So this is y equals negative 4. The highest y value that we hit, so we have this, we have all these points in between. It looks like this is the highest one. The topmost point, so the highest y value that we hit is y equals 7. So it looks like our range is going to be negative 4 is less than all of the y values in our graph, which are less than 7. And then because we have the open bubble here and the open bubble here, we can never actually hit either one of those endpoints. I'm going to leave it up to you guys to find the interval notation if you prefer that. For problem 3, if f of x equals 4x minus 8, then determine f inverse of x. So we had some steps for finding inverses. So step 1, turn f of x into y. So our equation becomes y equals 4x minus 8. This is still the same function that we started with. It's just y instead of f of x. Now is the step where we switch it to the inverse. So the inverse function is going to have switched input and output compared to the original. So we'll switch the x and y values, and x and y. So now I'm going to change colors because the new function that we're talking about, this is the step where it becomes the inverse. So we switch y for x, we switch x for y. Now this function right here, this is a new function, it is the inverse function. Next up, we have to do step 3, which is, it looks strange to have our y not isolated, so isolate y. So to solve for y here, I'll add 8 on both sides. That gives me 4y equals x plus 8. I will divide by 4 on both sides. I get y equals x plus 8 divided by 4. You can simplify this maybe to y equals 1 over 4 x plus 2. Nice y equals mx plus b form. And finally, because we made up y, we want to convert back to the variables from the problem. So the problem asks us to find f inverse of x, which means that now that we've isolated y, change y to f inverse of x. So y is f inverse of x equals 1 over 4x plus 2. Next up, we've got g inverse of x that we're trying to find, and I'm going to leave this one for you guys. I think that the algebra is very similar to what we had before. For problem number 5, we've got if f of x equals 3 over 4x plus 6, then determine f inverse of x. So we're going to follow the same steps as before. We'll do step 1, which is to make f of x into y. So we get y equals 3 over 4x plus 6. This is still f of x, just with a new notation for our output. The second step is now to convert it to the inverse. We switch x and y. Let me put a category over here, steps, and a line to divide it so it's clear. Switch x and y. So now this becomes our inverse function. We get x and y, and we fill in the rest of the details without changing them. All right, so now the only steps left are to isolate y, and then make your a substitution back. Oops, isolate y. So solving for y, we subtract 6 on both sides. That gives us x minus 6 equals 3 over 4y. We multiply by 4 to cancel this division by 4 on both sides. That gives us 4x minus 24 equals 3y. And the last step to solve for y is to divide by 3 on both sides. That gives us 4 divided by 3x minus 8 equals y, or y equals 4 over 3x minus 8. And finally, we need to change y to f inverse of x so that we use the variables from the problem. F inverse of x equals 4 over 3x minus 8. Last problem. So if h of x equals 4 over 3x minus 1 over 6, determine h inverse of x. The exact same problems that we've been doing, but the algebra looks like it's going to be a little harder this time. So let's see if we can figure it out. So we replace h of x with y. We now change to our inverse function by switching x and y. So I'll label this as the inverse so it's clear. And finally, all we have to do is solve for y, which seems like it might be a little harder this time. Let's give it our best shot. So my instinct here says with two fractions, I'd like to be able to combine them to make a single term that I can, solve algebraically with. So 4 over 3y, that's the same thing as 4 times y, 4y, over 3 times 1, minus 1 over 6. Now, in order for me to subtract these fractions, I need to have a common denominator. So to turn 3 into 6, I'll multiply by 2 on numerator and denominator. This will give me 6. I already have 6 here, so I will get common denominators. That gives me x equals 8y over 6 minus 1 over 6. Now that I have common denominators, I can combine these. That gives me x equals 8y minus 1 over 6. And I can't actually combine 8y and minus 1 because they're not like terms, but we can write them as a single fraction as below. Now, to solve for y, I'll multiply by 6 on both sides. That gives me 6x equals 8y minus 1. I'll add 1 on both sides. That gives me 8y equals 6x plus 1. I'll divide by 8 on both sides. That gives me y equals 6 over 8x plus 1 over 8. This fraction can be reduced, so y equals 3 over 4x plus 1 over 8. And for my final answer, I need to use the notation from the problem, which is h inverse of x equals 3 over 4x plus 1 over 8. So the exact same four-step process, but